Okay. So we're starting with example 1. It says, in the last lesson, we looked at several tables of values that represented inputs and outputs of functions. For example, tells us that we have bags of candy and how much they cost. One bag of candy costs $1.25. 2 costs $2.50. 3 costs $3.75. Today we're talking about something called a linear function. We talked about what a function was yesterday. Function just means every input has one output. So if you looked at your x values, was there anything repeated? 1, 2, 3, 4, 5, 6, 7, 8. Was there anything repeated in my x's? No, so we know that this is a function. What it means to be linear, what's the first 4 letters of linear spell? Line. So this means that when we graph it, it's going to make a straight line. Linear function means when you graph it, it's going to be a straight line. It's not going to have any of the curves or anything like that in it. It's just going to be a straight line. So that means for a linear function, we have to have a constant rate. So we're going to kind of move on and look at example 2. I guess if you wanted to, you could see if this had a constant rate. If you took 125 divided by 1, you'd get 125. If you took 250 divided by 2, you would still get 125. If you got 375 divided by 3, and you can start checking these because I don't know that off the top of my head. 375 divided by 3, I'm still getting 125. So as far along as I go, one bag of candy is still only going to cost $1.25. So that means we have a constant rate of this 125. That's how you know it's a linear function. Okay, example 2 says Walker walks 8 miles in 2 hours. What is his average speed? If you're talking about average speed, you're always wanting to do your distance over your time. That's going to tell you how fast you are going. So how far did he go? 8 miles. And how long did that take him? 2 hours. What is 8 divided by 2? Okay, and I know that it's going to be miles per hour because miles was on the top and hours was on the bottom. So this guy's going 4 miles an hour. I guess. I don't. Yeah, it says he walks. He's walking. So that is the constant rate that this guy's walking. It says he walks at a constant rate. That means he's not speeding up. He's not slowing down. He's going 4 miles an hour the whole entire time. Okay? That's what a constant rate means. Example 3 says Veronica runs at a constant speed. The distance she runs is a function of the time she spends running. The function has the table of values listed below. So if she runs 1 mile, it's going to take 8 minutes. If she runs 2 miles, it's going to take 16 minutes. 3 miles is 24 minutes, and 4 miles is 32 minutes. Since Veronica runs at a constant speed, we know that her average speed is going to be the same the entire time. And if you wanted to figure out her average speed, you would take the distance divided by the time. So we just need to look at one of the points right now. Her distance was 1 mile. The time was 8 minutes. So she runs 1/8 of a mile every minute is what that means. Okay, moving on to example 4. We're going to get to examples where you actually have to do some work here. But first, it says, water flows from a faucet into a bathtub at a constant rate of 7 gallons of water pouring every 2 minutes. The bathtub is initially empty and the plug is in. So what it means is when you turn the bathtub on, all the water is going to stay in the bathtub. Determine the rule that describes the volume of water in the tub as a function of time. If the tub can hold 50 gallons of water, how long will it take to fill up the tub? All right, so the first thing we want to do is figure out how many gallons does this bathtub fill up every single minute. So it fills up 7 gallons in how many minutes? 2 minutes. We're going to make an equation, set that equal to y over x. If you made a diagonal line from y, what number would it point to? So 2 and y are now together. If you made a diagonal line from x, what would it point to? 7x. To get y by itself, I have to divide by 2. So someone who has a calculator, which is actually everybody, take 7 divided by 2. That means it fills up 3.5 gallons in 1 minute. So it asks us to determine the rule. This is the rule. So this was the first question it asked us to do. But then it asks us to figure out if the tub can hold 50 gallons of water, how long will it take? Okay, well, let's think about our letters really quick. What did the 7 represent? Gallons, that's a bad G, but gallons. What did the 2 represent? Minutes or the time. So if I'm wanting to plug in 50 gallons, should I plug it in where Y is or where X is? Gallons was on the top. What letter was on the top? Y. So if we're plugging in gallons, it needs to go in where Y is. So 50 equals 3.5x. This is going to tell us how long it would take to fill up a 50-gallon bathtub. This is a one-step equation. The only thing I have to do to solve for x is divide by 3.5. So we all have calculators. Take 50 divided by 3.5. What did you say? So 14.2 minutes. So to fill up a 50-gallon bathtub, it would take about 14 minutes to do it. That's kind of a long time. I don't know how big my bathtub is, but I don't think it takes that long. Okay, moving on to the next question. Now you're going to assume that you're filling up the same exact bathtub. It's 50 gallons, same rate. The water's coming out at 3.5 gallons every minute, but this time the bathtub already has 8 gallons of water in the tub. Will it still take 14 minutes to fill up the tub? Someone raise your hand and tell me what you're thinking here. You have the same bathtub, it's filling up at the same rate, but this time it starts with 8 gallons already in the tub. Will it take the same amount of time? No, it should take what? Less time? Should take less time. Yeah, I don't know what the deal with that is. Should take less time because there is already water in the tub. I don't know. I don't really want to think about that. Maybe they turned it on earlier and had to go like fix dinner for their kid, and then they just had it in the tub. Yeah. Okay, now we have a table to fill out for this part up here. So at 0 minutes, it already had how many gallons of water in the tub? 8 gallons. So at 0, we had 8 gallons in the tub. Now we have to figure out for 3 minutes, 6 minutes, 9 minutes, and 12 minutes. So we're going to actually have a different equation here. It fills up at the exact same rate, which was 3.5 gallons per minute. But we have to add something to this equation because we know how many gallons we start with. We start with 8 gallons, so we have to put plus 8 at the end of our equation. Still goes at the same rate, but we have those 8 gallons you can't just forget about. You have to put that in your equation somewhere. So now if we're trying to fill out the rest of this table, we'd say if we wanted 3, you'd take 3.5 times 3 plus 8. So go ahead and take 3.5 times 3 plus 8. Okay, so that'd be 18.5 gallons like Tanner said. I want you guys to fill out the rest of this table. Okay, what should I get for 6 minutes? Sorry. 29 gallons in 6 minutes. What about 9? 12. Okay, so apparently in this situation it actually only takes 12 minutes, not 14 minutes to fill up the bathtub. Example 5, water flows from a faucet at a constant rate. Assume that 6 gallons of water are already in the tub. By the time we notice that the faucet is on, this information is recorded in the first column of the table below. The other columns show how many gallons of water are in the tub at different numbers of minutes since we noticed that the faucet was running. So, we know that we start with 6 gallons in the tub, but we still have to figure out our constant rate here. So we're only going to focus on these 3 boxes right now, not the one that's attached to the 0. I need to take 9.6 divided by 3. We all have calculators. It shouldn't take you very long to type that in. 9.6 divided by 3. Close. Yeah, 3.2. Okay. Let's try this one. 12 divided by 5. Sorry, I was looking at the wrong thing. And then take 16.8 divided by 9. 1.8. So do you see how we're not getting the same rate every single time? So how do we do that if we don't get the same rate every single time? Like we're not getting a constant rate. This is what we're going to go ahead and do. We started doing this the other day. We did actually a bunch of these problems the other day. We're going to focus on 2 points at a time. We're going to take this one and focus on this point. We're going to take the bigger number, 9.6, minus the smaller number, 6. And then we're going to take 3 minus 0. We're focusing on 2 points at a time here. We took 9.6 minus 6 and 3 minus 0. Can anyone tell me what 9.6 minus 6 is? 3.6. What's 3 minus 0? Nope, it's 3. You're right. Now take 3.6 divided by 3. 1.2. Okay, we're going to do the same thing. I'm doing this in a different color now. We're focusing on 2 different points. We're looking at the ones that I've circled in blue here. I'm taking the bigger one minus the smaller one. So if I'm looking in this column, 12 is bigger than 9.6. So I took 12 minus 9.6. Then I do 5 minus 3. Someone tell me what 12 minus 9.6 is. 2.4. What is 5 minus 3? Now we need to take 2.4 divided by 2. Yep. We're going to do one more, and I'm changing the color again so you can see we're focusing on the last two. This one in red right here. And remember, we're doing bigger minus smaller. So 16.8 minus 12, and then 9 minus 5. 16.8 minus 12 is 4.8. And 9 minus 5 is 4. Now we're going to divide. Once again, you get the same thing, 1.2. This is the number that we care about. You see how we got the same thing every single time? So when we come up with our equation for this table, you're going to start with y equals. Then you're going to write that constant rate down that we kept getting. We kept getting 1.2. After that, you're going to put your x down. And your very last number is how many gallons the tub started with at 0. So look at 0 and tell me what the number is. 6. It's a positive 6, so I'd put plus 6. That is the equation for that table that we just looked at. 1.2x plus 6. All right, we're going to keep practicing this, so move on to the next page. Now we're looking at where it says exercises, and then it says 1 through 3. Hannah claims she mows lawns at a constant rate. The table below shows the area of lawns that she can mow over different periods of time. 5 minutes, 36 square feet. 20 minutes, 144 square feet. It says if the data was consistent with the claim that she mowed at or is it a linear function, basically, is what they're wanting to ask. Okay, you could graph this and see if it made a straight line. If it makes a straight line, it would be linear. You could also see if we have a constant rate. So that's what we're going to do first. We're going to look at these two numbers right now. And you can think of this almost as finding slope. This is y1 and this is y2. This is x1 and this is x2. So it's the exact same thing as finding the slope of this table. Remember, the slope formula was y2 minus y1 over x2 minus x1. That's how we found slope, and we did that a lot last module. It's the same thing. I'm going to take y2, which is 144, minus y1, which is 36. On the bottom, I'm going to take x2, which is 20, minus x1, which is 5. And now I just have to subtract those numbers and figure out what it is. 144 minus 36. And 20 minus 5. So now we're going to divide those two numbers. 108 divided by 15 is what? Okay, that's the first one. We still have to keep doing this to make sure we have a constant rate. So I'm going to change the color of my marker again. We're now looking at two different numbers. This one here, right here. I'm going to take the bigger number minus the smaller number. I'm not going to label them like I did the last time. I'm just going to take 216 minus 144. And I'm going to take 30 minus 20. 216 minus 144. 72 divided by 10 is the same thing that we just got, 7.2. And the last one we're going to do are those last two numbers. It's in green right here. 360 minus 216. And then 50 minus 30 on the bottom. Yeah, and then 50 minus 30. And if you divide, you still get what? 7.2. Okay, so I think we honestly just did the problems that we were supposed to do on B, C, and D. But we describe in function, so we're going to do A together, or sorry, B together. The total area mode write this down. So what I'm looking at is the Y. You want to say, you see how it says the area mode for Y? You want to write down your Y first. So I said the area mode, and you're going to say is a function of. And then you have to go figure out what your X stood for. So I'm going to go back to my table and I look at my X. It was talking about minutes. Minutes is the same thing as time. So I'm going to say the total area mode is a function of the time. We already did C. We just did all of this work. We took 36 divided by 5, got 7.2 square feet. We could take for 20 minutes, we had 144 divided by 20, we got 7.2 feet. And 30 minutes, we had 216. So we're getting 7.2. We already did a lot of that work, so I'm just kind of quickly writing it down. The last one is 360 divided by 50. We got 7.2 again. Now it says write an equation. Well, what number did we keep getting over and over again? So y equals 7.2x. Okay, now this is where the common sense comes in. We are mowing yards and it takes time to mow yards. What kind of numbers can we not plug in for X or Y? We're talking about mowing yards. So, and then we're talking about time. You can have fractions. You could mow like a half a yard. You cannot have negative numbers. So no negatives. We talked about this yesterday because we were talking about doing math problems. I have never in my life heard a teacher say, okay, we're going to do -7 problems tonight. It's going to take about -10 minutes. That's not going to happen. They're not going to say that. And also, someone who mows yards is never going to be like, hey, Mom, I'm going to mow like -4 yards today. I'll be back in -30 minutes. I've never heard anybody say that. It's not true. That's why H says we cannot use any negatives. Now we're on I. What number does the function assign to 24? So here's our equation. Y equals 7.2x. If I want to know x equals 24, I'd take 7.2 times 24. We don't need to be packing up or anything, you guys. We're fine. 7.2 times 24. 172.8. That means in 24 minutes, we can mow 172.8 square feet. Then it says, according to this work, how many minutes would it take to mow an area that has 400 square feet? So if we're mowing, that number has to go in for Y, not for X. Because X stands for time, and 400 square feet is not a time. So what you do here is you divide by 7.2, and then you get your answer. So 400 divided by 7.2. Yeah, we're going to round it to 56 minutes. So to mow 400 square feet, it takes about 56 minutes. Okay, we have one more thing we're going to get through, and we're running out of time. So the next one on number 2 says a linear function has the table of values below. The information in the table shows the total number of water in gallons that flows from a hose and the number of minutes that the hose has been running. It says describe it in words. So what does our Y stand for? Okay, so we're going to say the total volume So we say what our y stands for, and then we'll write is a function of. And what's our x stand for? Time. So we say the total volume is a function of the time. All right, we're gonna do B as well. You guys have B on the very back. I don't know if it's on the very back. We're on B. I want to leave it up here so I can see my table. We need to take our y divided by our x. So we're going to take 44 divided by 10 and see if we keep getting the same number. 44 divided by 10, what do you get? Okay, if you wanted to take 110 divided by 25 to see if you get the same thing, I'm going to speed this up. We get the same thing every time. We keep getting the number 4.4. So on B, our equation is y equals 4.4x. What number does the function assign to 250? We're going to say 4.4 times 250. Someone do that and tell me what you get. 4.4 times 250. 1,100 gallons is how many gallons you'd have in 250 minutes. B says the average swimming pool holds that many gallons of water. Y equals 4.4x. So instead of plugging it in for x, we're plugging it in for y. This is going to tell us how long it's going to take to fill up a pool that holds almost 18,000 gallons of water. So I'm going to divide that number by 4.4. 17,300 divided by 4.4. That's minutes. Oh, shoot, I didn't even pay attention. Oh, wait, this is different. Oh, it says that a pool's already been filled up a quarter of its volume. So now we're going to take that number divided by 4. Take that number divided by 4. Okay, we don't have time. Put it up, we'll finish it tomorrow.